Okay, hello Cha, good evening. Hello, good evening. I hope all of you are doing well. So today we are starting the topic concentration terms, right? It is depending on the mole concept, okay? And a very important topic. These concentration terms will be used in many chapters like equilibrium, thermodynamics, solutions, okay? And this chapter definitely, first chapter also. Okay, Shakin, good evening. Karthik, hello. Okay, bacha, let us start then. The topic is concentration terms. There are 8-9 important terms. We will discuss it step by step, okay? And then we will see the relationship and some of these terms, or I will say you can divide these terms in two parts. Some are temperature dependent and some are temperature independent. So we will understand this topic also, how and why they are temperature dependent and why some of these are temperature independent, right? Okay, Lakshmi, good evening. Okay, bacha. So first of all, I am taking very basic things. First I am taking here, it's a weight by weight percentage. You will see this many times in questions. Weight by weight percentage is the first term. If they are giving you a solution and in the solution they are writing it is this much weight by weight percent of this. So what that means, right? So what is weight by weight percent beta? It means weight of solute. Weight by weight percentage of solution means weight of solute divided by weight of solution into 100. Simply like we find percentage of something, right? So similarly, weight of solute in the solution divided by weight of total solution into what? Into 100. It is our weight by weight percentage. Okay. The next number if I take, or if I take a simple example before that, I am taking simple example. Imagine this is a solution. This is containing 20 gram. This is containing 20 gram glucose. So here 20 gram glucose is present and I am saying here the total solution is 200 gram. Total solution is 200 gram, right? Tell me what is the weight by weight percentage of solution? Tell me. Yes, beta. Tell me what is the weight by weight percentage of given solution? Solute weight divided by total weight into 100. So please answer me fast. Yes, beta, answer me fast. One more example I am taking here. And both of you have to answer. Right? The second term is here I am saying we are having 15 gram of urea in this. This 15 gram urea here, imagine. And here we have, imagine I am having, you can say 75 gram. I am saying here 75 gram water. Be careful, I am saying here 75 gram of water and water is my solvent here. Water is my solvent. Okay. Shania is saying 10. Okay, for first one you are saying 10, right? For first one, how much coming? 10. Very basic thing, beta. And here also your task is to find weight by weight percentage. Okay. What's coming? In first case, if you try to find the weight of solute, how much? 20 gram solute divided by how much solution? Solution total weight 200 into 100. Yes, beta, what is coming? 10%. It is 10%, right? In this case, tell me what is coming. Yes, everyone? The second one is little different. Don't make mistake here. Find the weight by weight percent. Be careful, it is the weight of solute, it is the weight of solvent. In weight by weight percentage, I have to take the weight of solution. Tell me, in the second case, okay, Lakshmi saying 16.67. Fine. 16.67. What is coming? 15 gram. It's 15 gram urea. Total beta how much? 75 plus 15. 75 plus 15, how much? 90. Be careful, total weight of solution I will take, not solvent only, into 100 coming. The 15 giving beta 6, so how much coming from here if you solve it? So 6, 1, 6, 4 is coming, so 16.66%, right? 16.66%, very good. The main thing here is you have to take the weight of solution, not solvent. So in this case, you have to find solution weight by adding solute and solvent, right? Good. Fine. The next thing, the next term I am taking here is our weight. Okay, before that I am taking volume by volume. More easy. The second term is volume by volume percentage, okay? What is that? Very simple thing again. Volume of solute. Volume of solute divided by volume of solution into 100. Both terms are present in volume, okay? The volume of solute divided by volume of solution into 100. Be careful, if you are taking here gram to gram, milligram to milligram, both units must be same. Here also, if it is liter, liter, ml, ml, so both units must be same, so that it will cancel out and nothing will remain, okay? Fine. A simple example better. Simple example again. Here I am saying, imagine here we have 15 ml HCl. This is 15 ml HCl I am saying here, and here I am having, it's a 120 ml solution. Total solution is 120 ml, okay? And out of that solute is 15 ml. So tell me volume by volume percentage of solution. Volume by volume percentage solution, right? Yes, Mr. Renuka, good evening. Please give me answer. Fast, fast. Volume by volume. Very easy again. Volume of solute divided by volume of solution into 100, right? So if we cancel out this, zeros will cancel out. Now solve it. What's coming? 3 into 4 and 3 into how much? 5. So 50 by 4 is coming. Or I can say cut it down. What is coming? 50 by 4. But how much coming? That means 12.5. Right? 12.5%. Very good. Lakshmi, Shranya, Monica, right? So it is very simple term. Simple terms, right? Okay, nice bache. Done up to here. I am taking the third one. That is weight by volume, okay? Direct question, like it is less chances to ask direct question from these terms, but these terms will be used in next terms like molarity, normality, mole fraction, right? Okay. So the next term I am taking here is weight by volume percentage. It's weight by volume percentage. What we have? It's weight of solute. Here we have weight of beta solute and divided by volume of solution. So upside we have weight, but downside what we have? Solution. And be careful, as both are different things. It is weight, it is volume. So carefully take the weight in gram and take the solution volume in ml into 100, right? So here we have to be careful, because one thing is weight, one thing is volume. You have to take weight in weight in grams and volume in ml. In the previous cases, both were same, so you have to take both same, gram or ml. You can take anything but same. Okay, good. Very easy again. One small term. Look at this again. It's a solution here, and I am saying imagine it is having here 8 gram glucose. Here 8 gram glucose is present, and I'm saying here we are having, imagine, you can say 60, or I'm saying 64 ml of solution. 64 ml solution. I am giving you simple data so that you can solve it easily. Otherwise, in points will come. It's weighed by volume now. Data can be anything, right? So 8 gram of solute divided by volume of solution. How much? 64 ml into 100. Nothing tough here. 8 will come, right? What's coming from here? Yes, 8 beta. 8 will come here again. Same thing is coming. 12.5 coming. Yes, 12.5%. Good. Fine. Sometimes I'm saying what I'm saying here. Okay, I'm giving a reverse question like this one. Question is find weight of glucose present. Find weight of glucose present in 400 ml of 8% weight by volume glucose solution. This is given. Imagine. This is given, right? So in the question they have given us, but weight by volume. They have given us weight by volume percentage. So in the formula you see beta what is not given. Tell me the answer fast. Yes everyone. 8 is the percentage, right? They give the percentage. Weight by volume percentage is 8 equals to, I want to find weight of solute, or I can say I want to find weight of glucose here, right? Divided by volume of solution. How much is solution volume? 400, and here into 100, right? Yes, very good. So from here weight of glucose is coming beta. How much? Is coming how much here? 32 grams. So we should be very much clear about the formula. Yes, Yamini, Shanya, Monica, Pragna, Lakshmi, yes, everyone gave right answer. Very basic thing. What I was saying, like less chances are there to ask direct question from here. But these terms will be used in finding the other concentration terms, right? So understand this very carefully. Imagine in a question, they gave you this data. They're writing that it is, imagine it is 15% weight by weight glucose solution. Someone gave you this data. They gave it is a 15% weight by weight glucose solution. Nothing else given. And they're asking some other term. So how you will use this term, right? It is very important. You have to use this term beta. How? What you will conclude from here? You will say from here, sir, 15 gram glucose present in what? Present in 100 gram solution. So this is the main thing you have to understand from the above line. If they have given nothing else, just they gave 15% weight by weight glucose solution, it means you have to understand 15 gram glucose is present in 100 gram solution, right? So 15 grams of glucose and remaining 85 gram what? Remaining 85 gram solvent. You can say water. If they are not mentioning what is solvent, so it is water only, right? Clear? Done? Now imagine by chance they are saying it's a 20% weight by volume. Okay, I'm saying HCl solution. Imagine they are writing here, we have a solution 20% weight by volume HCl solution. Okay, so what that means? you have to take it as, it means 20 gram HCl in 100 ml solution. So you will take this line in this form, and then using this line I will try to solve my question. I will take many examples, don't worry about it. In the next terms I will use it, you will see by yourself, okay? But if they write this line, so you have to write it this form. It will give you yes, it will give you the clarity about the rest of the part. Okay, from here what I learned, it means I can say if I have 20 gram HCl, right? 20 gram is HCl, so 100 ml is solution. 100 ml is solution, right? If you want to find the weight of solvent, then I need density. Okay? I will use it, don't worry about it. Okay, Chetan, got the point? Fine. I will use it, don't worry. Okay. Now the next term. The fourth term I am taking. Yamini beta, 80 ml water we can't say. 80 ml water we can't say. I will take example, don't worry. We need density if you want remaining part. In this case I can say that if I have 15 gram glucose in 100 gram solution, so I can say that, in other words I can say 15 gram glucose, remaining beta 85 gram what? Water, right? But in this case I can't say, I need density to give the other data remaining. Okay, got the point. The next term is mole fraction. I will use in mole fraction the previous terms, just I said. Okay. The next term is mole fraction. Fourth term I will say. Mole fraction, right? So you will see, imagine in a box or in anything, I am saying I have three components. First component is A, second is B, third is C. Na are the moles of A, and B are the moles of B, and imagine NC are the moles of C. It can be a solution, it can be a mixture, or it can be, you can say, it's a box having three gases. Total box is having three components, A, B, C. Mole of A given, mole of B given, mole of C given, right? So out of this, if someone is asking, tell me the mole fraction of A, right? So what that means? Mole fraction of A means moles of A divided by total moles, right? So what that means? I'm writing here, mole fraction of A means moles of A divided by total moles, right? Total moles beta, you can see, I will say Na, mole of A divided by total, Na plus Nb plus Nc, right? Very easy term here. Okay. Similarly, if you're asking, sir, what is the mole fraction of B? What is the mole fraction of B? I will say moles of B divided by total moles. Moles of A, moles of B, moles of C, total, right? Similarly, beta, what is the mole fraction of C? Mole fraction of C is moles of C divided by total moles. Moles of A, moles of B, and moles of what? C, total moles. Right? Getting my point? So for whatever component you have to find the mole fraction, take its mole above side and divide by total moles, right? Okay. Yes. Shrinya, right beta. Very good. Okay. We will use our mole formulas also here. You will see step by step I'm moving. First one more thing. Mole fraction beta, mole fraction of all the components sum will always be equal to what? 1. When I am talking about fraction, in case of fraction, total thing is considered as 1, right? Like in case of percentage, total thing is how much? 100, right? Imagine out of total money you want 50%. So in percentage you will say I need 50% money. But in terms of fraction you will say I need half of the money. So in fraction when I am talking about, you will say half. Whereas in percentage you will say 50%. So I am saying once again, whenever I am discussing the fraction, so in the fraction total thing is considered as what? 1. So out of 1, how much part A will have, how much part B will have, how much part C will have, right? That's why the mole fraction of all the components will be equals to 1. Okay? Sum of the mole fraction will be equals to 1. I'm writing here. Sum of the mole fractions of all the components. Be careful. Not just some of the components, all the components. Will be equal to 1, right? Okay. If there are 4 components, the sum of the mole fraction of all the 4 components equals to what? 1. Okay. Done. Great. Now look at this. In this question, you have to find the mole fraction of both components. Like here, it's a solution. Imagine beta here, I'm saying we are having 80 gram. I'm saying we are having 80 gram of NaOH. In solution, we have 80 gram NaOH, and I'm saying here, imagine 180 gram water. In this solution, there are 2 parts. First part is solute, that is 80 gram of NaOH, and second part 180 gram of water. So my question is to find the mole fraction, right? I'm saying please find the mole fraction of NaOH. Can you find? It means moles of NaOH divided by total moles, right? Total moles means mole of NaOH plus moles of water, right? Sorry. Yes, better. Please answer me. First, find the moles of both. How we find the moles? Given weight by molar weight, right? Give me answer. Chaitanya saying 0.16. Okay, let us see. Yamini saying 0.16. Okay, beta. Let us find how many moles of NaOH are present here. How many moles? 80 gram is the given weight. Divided by what is molar weight, beta? Molar weight is 40. So yes, we have 2 moles. We have 2 moles of NaOH. Now here we have 180 gram of water. Let us find the moles of water also. How many moles, beta? 180 divided by how much? 18. So what is coming? 10 moles. Fine. So we have moles of both the things. Now it's very easy to find the mole fraction. Moles of NaOH 2 divided by total moles. 2 plus 10. So what's coming here? 2 by 12. It means how much? 1 by 6. Yes, 0.16 something. Good, right? Is the right answer? If you try to solve this thing, what's coming? 0.166 something. Right, everyone? Great. Fine. Now, next question I am saying here. Try to give answer. As I said, if they give you weight by weight percentage, how you have to use it? Okay, I am giving one question. Find mole fraction of NaOH in its aqueous solution, means solution of water and NaOH. Find mole fraction of NaOH in its aqueous solution if, okay, in aqueous solution in, or I will say if it is 10% weight by weight NaOH solution. Right? So they gave me weight by weight percentage. They are saying we are having 10% weight by weight NaOH solution. In that solution, find the mole fraction of NaOH. I told just few minutes back how to use this line. They are saying 10% weight by weight NaOH solution. Use this line. Use this line. I told just few minutes back, and then try to find the mole fraction. Yes, everyone? It's a weight by weight percentage, right? It's a weight by weight percentage. Right? Give me answer fast. Karthik is saying 0.25. Okay? So what is the writing here? They're writing we are having 10% weight by weight NaOH solution, right? And in this solution, they're asking what is the mole fraction of NaOH. How we will write this? What is the meaning of this? It means beta, we are having 10 gram NaOH. It means 10 gram NaOH in 100 gram solution. Yes, we have 100 gram solution. Okay? Or I can say here, if I go a little extra, 10 gram NaOH and plus beta what? Remaining is 90 gram what? Water. Right? Now it is very easy to understand how to find the mole fraction. Right? Yamini saying 0.04. Lakshmi saying same. Monica also same. Right? Okay. So from here, if I have the weight of both things, solute and solvent, can you find the mole fraction of NaOH? Yes. Moles of NaOH, how much beta? Moles of NaOH 10 by 40. Right? So I can say from here it is coming 0.25, right? Okay. And 90 gram water. So how many moles of water we have? 90 by 18. How many coming? 5. Right? Clear, bacha? Is everyone we are clear about this? Okay. So fine. The next thing, if you see, I want to find the mole fraction of NaOH. So very easy. Moles of NaOH, that is 0.25, and divided by total moles beta, 5 plus 0.25. Fine? Clear? So if you see what is coming, 0.25 divided by what? 5.25. It's coming 5.25. Fine? If you solve this thing, what is coming? What's coming? I think it's coming 1 by 21. It's coming 1 by 21. Check everyone. Yes? From here, 10 gram was there, so 10 by 40. So 1 by 4, how much? 0.25 is coming. Okay? 90 by 18, how much coming? 5. Mole of NaOH, how much? 0.25. Total moles, how much? 5 plus 0.25 means 5.25. If you cut down this thing, what is coming? 21 is coming. So 1 by 21. In terms of point also, you can say no issue. Yes, beta. Right answer only. If you find in points, you are saying right, 0.04 something will come. Okay, done. So this is the main thing, how to convert weight by weight percentage into what? Mole fraction. I am giving one reverse question also. Are we clear about this? Okay. One reverse question, right? find the weight by weight percentage of NaOH solution, right? If mole fraction of NaOH in solution is, okay, you can say, I'm saying 0.25, right? Mole fraction is 0.25, or let me take a little simple. Okay, fine, it's fine, you can take this one. Calculations can be lengthy, it's fine, not a big issue. Let us understand, I'm telling you this. It is reverse question, right? The question is mole fraction is given. Mole fraction beta of NaOH, they gave us, actually what is the mole fraction? It means moles of NaOH divided by total moles. That means moles of NaOH plus what? Moles of water, right? This is given as 0.25. They gave this as 0.25. I can write it as 0.25, or I can write 0.25 by 1, right? Same thing, na? If I divide by 1, nothing will change. So if they gave me mole fraction of something, so I can assume that it is just assumption. If I will take total moles 1, so out of that I will say mole of NaOH how much? 0.25, and total moles how much? 1. Right? So from here if I take mole of NaOH, mole of NaOH is how much? 0.25. Total moles how much? 1. So what is the mole of water? I can say it is 0.75. So from the mole fraction data, I get the idea. I put the formula equals to the given value. I am equating the numerators with each other, and I am equating the denominators, right? So 0.25 is the moles of N which I am taking. So total moles become how much? 1. Out of that, 0.75 is the moles of H2O. Okay, right? So from here I can say total weight of water, how much beta? If mole are this much, so what is the weight of NaOH? I can say, how will I find the weight? By the moles into its molar mass. 0.25 into 40. So from here, how much coming? 10 gram is coming, right? Mole of water we have, so we can find the weight of water. What's coming here? It's 0.75 into what beta here? 18. It's coming 18, right? So how much coming from here? If we say it's 0.75 into beta how much? 18 is given here. So how much coming from here? It means it is 3 by 4 is beta. 18.5 how much will come? 9. 18.7 how much? 126. So 135 you can say. So you can say it is coming 13.5, right? 13.5 gram. Right? 13.5 gram is coming from here. So now I want to find the weight by weight percentage. How much is coming from here? I can say 10 gram is weight of NaOH, and total weight how much? Total weight 10 gram plus 13.5. How much coming? 23.5 gram into 100. So whatever come from here, we are just moving reverse way. We are moving just reverse way, right? Okay. So these questions are very important when they give you one term and they ask you other term. So from the definition, you have to assume something like this one and then find the other term. Are we clear about this? Sometimes calculation can be a little lengthy, but we have to do if it comes in the exam. Okay. Shakin is saying it is coming 0.425. it's coming almost 0.425. No, 0.425 will not come, definitely. Something else will come. Okay, 42.9 approximately. Okay. Okay, 42.9% approximately, I'm saying. Calculations you can do by yourself, okay? 42.5. Okay, bacha. Right, good. Okay, this is it. So up to now we have seen 4 terms. Weight by weight percentage, weight by volume, volume by volume, and mole fraction. We will use these terms in the incoming next terms, right? Fine. Okay, bacha. Okay, 42.9, 42.5, it's okay. You can check by yourself. Fine, bacha. Right, but you did right only. Next one. The next term is, right, beta, molality. The next term is molality, right? We show it by small m. Actually, some students always remain confused about molality and molarity. So be clear, I am discussing now. Molality means small m. Molarity is capital M. Okay, we will discuss it after that. So I am discussing first molality. What is the meaning of that, beta? What's molality? Molality is what? Number of moles of solute. Number of moles of beta solute and divide by weight here. It's a weight of solvent in kg. Okay, this topic is formula based topic. If you remember topic, you can give answer, otherwise not. So molality is moles of solute, number of mole of solute divided by weight of solvent. I am saying once again, 2 terms are there. First of all, here I am taking just solvent. And second term is weight, it is not volume. Weight of solvent, in which terms? Kg. So try to answer this question, right? I'm taking one simple example. Imagine we have a solution here. In this solution, we are having 20 gram NaOH. I'm taking here 20 gram NaOH. And here we are taking 200 gram of solution. Sorry, I'm taking solvent. First of all, I'm taking solvent, right? So 20 gram NaOH and we are having 200 gram solvent. So you can take water if they don't mention anything else. Tell me, give me the answer, beta. We had to find the molality of solution. Is everyone fast? Okay. Give me answer. Waiting. Okay. Chaitanya is saying 0.2, Chaitanya is saying 2.5. Let us see. Who is saying right? First of all, we have to find the moles, right, beta? Mole of solute. So how many moles we are having here? Be careful. 20 by 40. First find the moles, right? What's coming? Half mole coming, 1 by 2 moles. So I'm taking here half mole. 1 by 2 moles divided by 200 gram of solvent. I have to take in kg. So to make it kg, I will divide it by 1000. Or I can say 1000 will go where? Upside. Okay? So what's coming finally, beta? If you divide, it is cut down 5 coming here. And it is 2 downsides, so 5 by 2. Yes, what is coming? 2.5 molal. 2.5. Okay. Right. Most of you gave same right answer, 2.5. Vishnu, beta, how you are saying 0.2? One student is writing 0.2. Sharanya also saying 0.2. Check how you are saying 0.2. How 0.2 is possible? You have to take mass in kg. You can't take mass in grams, right? Be careful about it. It is the mole of solute divided by what? Weight of solvent, right? Okay, be careful about it. Now, one more thing I'm saying. Carefully give the answer. This is a solution here. Okay, and in this I am saying we are having 60 gram. We are having 60 gram glucose here. We are having 60 gram glucose, and I am saying we are having 3 or 300 gram water, or I am saying 300 gram solution. Find molarity of solution. Be careful, 300 gram is the weight of solution. I am mentioning very clearly, this is weight of solute, it is a weight of solution. You have to take care. You are taking the weight of solvent in molality. You will not take the weight of solution. Okay? So please give me answer. Fast, fast. Arjun saying 1 is coming. Okay, Arjun, we'll check beta. Okay. Any other answers? 1.11. Shakeen saying 1.11. 1. Okay, we'll check. Yes, beta. Carefully give the answer. First of all, be clear what we need. I need mole of solute. So 60 by 180. First of all, I have the weight of solute, so I'll find the mole of solute. Mole is coming 60 by 180. Right? Divided by weight of solvent, beta. I need weight of solvent. Be careful. Here solvent is what? Water. What is that? Weight of solution minus what? Weight of solute. So I will get 240 gram. 240 gram is the weight of solvent here. Be careful. I need weight of solvent. I don't need weight of solution in finding molality, right? So what's coming here? 60 by 180, and here how much? 240 gram. To make it kg, I will divide by 1000, or I can say I am multiplying upside by 1000, right? So what's coming from here if you solve? 60 by 180 is coming what? 1 by 3. 1000 upside coming. 1000 upside. 3 coming downside. 3 here, and how much here? 240. Right? This is coming. If you solve this, what is coming from here? You can cancel this little bit from here. So 4 you can take, but 4 is coming. How much? 25 will come down upside. 25 and 6, 3, 18, right? This is coming. Yes, I will take 1 here. 1 is coming, and how much remaining? 7 remaining. Yes, 1.3 something will come. 1.3 something you can say. 1.38, right? 1.38, good. Or 1.39 something, right? 1.38 molality. Shakeen gave right answer. Yamini also right, beta. Lakshmi also right. Okay, many are writing 1. You have to calculate, beta. You can't say just 1. You have to give proper answer. 1.3, 1.34, whatever coming. Okay, but good. Most of you did the right. Fine. I hope we are clear now. Now let us try to connect the molality with the weight by weight percentage, right? Okay. Look at this. Question is, find molality of and find molarity of a 10% weight by weight NaOH solution. This is the question. As I said, this weight by weight term will be used in many other terms. Okay? So again, you have to understand what this line is saying. Use this line properly and try to find the answer. Right? What this line is saying? Line is saying we have 10% weight by weight NaOH solution. So it means what? It means 10 gram. It means 10 gram NaOH in 100 gram solution. Right? This is the meaning of the line. Now whatever you want to take from here, use it. Give me answer. Yes, beta. 2.2. Chaitanya is saying 2.2. Right? 2.7, 11.1. Shakin is saying 11.1. Okay, let us see, beta. Yamini is saying 0.27. So why so much variation this time? Everyone is giving different answers this time. See carefully what they are trying to say. From the above given question, we can understand that we are having 10 gram NaOH. We are having 10 gram NaOH in 100 gram of what? Solution. Right? I can say from here that we are having 10 gram to NaOH. Total 100 gram solution means 90 gram is what? 90 gram is water. Total is 100 gram solution. So 10 gram solute. So 90 gram what? Solvent. Right? So from here, now it's very easy to get the molality. What is molality, beta? Weight of solute. So divided by molar mass. 10 by 40 mole of solute. Divided by weight of solvent in kg. Right? Weight of solvent in kg. Okay? Fine? So from here, if you want to solve it, what's coming here? 1 by 4 here. This will cancel this one. 100 coming upside, and here is coming 4 into 9. 36, right? If you solve this thing, it's coming 25 by 9. 25 by 9 is coming. 25 by 9 is coming? Yes? If you solve this thing, beta, what is coming? 9 to 18. 2 point something is right answer. 7 is there. 2.8 I can say, or 2.79 something like that. 2.7 something you can say that. Okay, Lakshmi gave right answer. Monica also gave right. Chetan, yes, 2.2. So no, not 2.2, sorry, 2.7 something, or approximately 2.8 you can say. Right? I hope we are clear. I am giving one more question on this basis. Please, this time give me right answer. In the previous question, many students made mistake. So give me right answer this time, everyone. Easy question I am giving here. Please find molality of you can say calculation can be a little lengthy. It's 18% weight by weight urea solution. Calculations can be a little lengthy. Check, but find molality of 18% weight by weight NaOH solution, sorry, urea solution. Or just to make it a little easy, let me write it as the glucose solution, okay? Okay, glucose I am giving 18% glucose solution. They can give you anything, whatever they give, you have to solve it, right? The first thing is to be clear what they are trying to say. Whenever this line is coming, it means they are saying 18 gram glucose in 100 gram solution. They are saying this thing. So from this we are very much clear that weight of glucose in solution to how much is 18 gram, and weight of water beta or weight of solvent, I will say, if they don't give solvent then is water only. So how much out of 118, this much, what remaining? 82 gram. Okay, 1.2, 1.21, 1.21, fine. Let us check then. So what's coming from here? I want to find molality, mole of solute, 18 by 180. How we find the moles of solute? Given weight of solute divided by molar mass of solute, right? 18 by 180, because glucose have how much molar mass? 180. 18 by 180, and what is it? 82 gram is the weight of solvent. Make it kg beta, make it kg by 1000. So from here if you solve 18 into 180, how much coming here? 10. 1000 is upside. 1000 upside beta, it will cut down one of the 0. So 100 by how much coming? 82. Right? So 100 by 82 is coming. So if you solve this thing, what is coming? Okay, 1.21. It's better, it's 1.21. It's 1.21 molar. You are saying 1.2, I am writing that part. It's better. Okay, it's better. This is your, you can say, bridge course for the NEET 2026. For JEE, you can check better in the YouTube. You can check if classes are there. I think classes are going on. You can check that part. Right? Okay. The next thing. So this is it. This is our molality and what? Our, you can say, weight by weight percentage relationship. Clear? Now, fine. The next thing is, I am giving the questions in which then we will see shortcut also, in which we will see the relation between the molality and mole fraction. Let us see, first of all, I am giving you one shortcut. Using that, you can find your molality if they give you mole fraction. Now I am connecting the mole fraction topic with the molality. Okay? And after that, you will see, we will understand how it is coming also. First of all, use this shortcut and save some time. After that, we will understand the concept of how it is coming. So, if you want to find molality using the mole fraction of solute, so we write the formula, it is 1000 here, 1000 into x. What is x here, or chi you can say, mole fraction of solute, divided by 1 minus mole fraction of solute into molar mass of solvent, into molar mass of solvent. This is the relation between the mole fraction of solute and the molality of solution. In most of the questions, or I will say always, our solvent is found to be what? Our solvent is found to be water. So in that case, if you take it 18, if you take solvent as water, then what is the molar mass of solvent beta? Solvent molar mass become how much? 18. So if you put this 18 here, this 18 cut down this what? 1000 comes how much? 55.5. So I can write the direct relation also from here. 55.5 into mole fraction of what? Solute, divided by 1 minus mole fraction of solute. Right? This formula you can use anywhere if any solvent is there. But this you will use when solvent is water. And as I'm saying in the NEET exam, always solvent will come as water. So you can use this one. Okay? Molality, small m is molality, and chi or x you can say here is the mole fraction of solute. Are you clear? So I am giving you one question. So you can solve it using this shortcut. Okay? Very important, very important. It will be used in many questions in different chapters. Especially I will say chapter solution. Okay, 12th class chapter, second chapter if you see. After the solid state, they gave it in NCERT. Okay, bacha. Done up to here. Can I take next slide? I am giving one question on this basis. Is it right? Is it done? Fine then. Okay. Simple question. Question is find molality. Find molality of an aqueous glucose solution if mole fraction of glucose in solution is 0.2 0.2 is the mole fraction of glucose or solute in the solution. Using this, find the molality. Just now I gave a shortcut, direct relationship of molality and mole fraction. So using that, please find the answer. Right? Fast, find. Aqueous solution, I'm saying aqueous solution means a solvent is water. So you can use direct second relationship. 55.5 into x divided by 1 minus x, where x is mole fraction of solute, right? So how we'll find the molarity? It is a molarity formula here. So 55.5 into x, beta, what is x? 0.2 divided by 1 minus x, what is x? 0.2. 0.2 here, 1 minus 0.2 here. So here we can say beta 55.5, 0.2, 0.8, it will give you what? 4. Very good. Yes, everyone is saying I think 13.8 is coming. You are saying 13.8, right? Great, that's it. Okay, great. Fine. If you remember the shortcut, it's very easy to go, right? By chance, if you become Gajani and you forgot about the formula, sir, what was the formula? I don't know. So again, we can go, it will take little extra time, but still I'm telling you a little bit. They gave you what? Mole fraction, beta. They gave you mole fraction of glucose. Mole fraction of glucose they gave you, it means you have moles of glucose divided by moles of glucose plus moles of water. They gave you this thing, right? If you know the shortcut, then there is no need of doing this. You directly go by this one, right? How it is coming, I am telling you that part only. Mole of glucose you have, mole of glucose plus mole of water, this is given as 0.2. It is 0.2 given. I can say 0.2 just, or I can say 0.2 by 1. Now we equate, beta, we equate the numerator to numerator and denominator to denominator, right? So mole of glucose how much coming? 0.2. And total moles how much coming? 1. So from here, by equating the numerator and denominator, I can say that we are having how many moles of glucose, beta? We can say from here Mole of glucose how much? 0.2. And we can say mole of water how much? Total moles how much? 1. 0.2 gone. How much remaining? 0.8. So from the mole fraction topic, I can clarify this part, right? Mole of glucose 0.2. Mole of water how much? 0.8. Now you know very well what I need for molality. For molality, I need mole of solute, that is 0.2. But I need weight of solvent. From here, if you try to understand, if I have mole of water, I can find weight of water. How? Mole into molar mass, 18 gram, right? So from mole of water, I got the weight of water, that is 0.8 into 18, right? 0.8 into 18. But it is gram. To make it kg, I will use what? 1000. So in you will see finally same thing will come, right? If you know the shortcut, it's very easy to save you time. Otherwise, you can see finally same thing is coming, right? If you cut down this 18 and 1000, what is coming? 55, right? 55 is coming. Upside 0.2, downside how much? 0.8. Check that part. This thing and that thing is same only. So if you want to save your time, you use the shortcut directly this one. Okay, the concept is this one. The conceptually this one, right? Yes, great. Okay, I hope we are clear how it is coming. I'm telling you the whole thing. You should know the shortcut also and the concept also, right? Okay, great. Now, please, on the same basis, one more question I'm giving. Please try. Find molality of a given NaOH aqueous solution, right? If mole fraction of water in solution, they have given mole fraction of water, but be careful. If the mole fraction of water is 0.9, the mole fraction of water is 0.9 this time. Instead of giving mole fraction of solute, they gave mole fraction of water. So be careful what to do. Yes, bacha. Fast. What's coming? Just put the formula, get the answer fast. Okay, Shagini is saying 6.16. Is your Karthik saying 6.6? Okay. Good. 6.16, Yamini. Okay, 6.16 is answer is coming from most of the students. You can see, beta. First of all, if mole fraction of water is 0.9, what is the mole fraction of beta? If I say solute, or solute is NaOH, right? Total sum of mole fraction is 1. If mole fraction of solvent is 0.9, what is the mole fraction of solute? 1 minus 0.9, that is 0.1. So I have the mole fraction of solute now. I can apply it very simply to get the answer. Yes, the molality is 55.5 into 0.1 divided by 1 minus 0.1, right? So if you solve this thing, what is coming? 55.5 divided by how much coming, beta? 9 is coming. Okay, so from here I think what's coming? 6.16 molar. It's coming 6.16 molar, right? Okay. Most of you get the right answer only. Fine, very good beta. Okay, great. Great. Done? So very simple term we have seen beta. We have seen up to now molality, mole fraction, and weight by weight percentage, weight by volume, and volume by volume, right? A small term I am giving strength. A small term I am writing now strength. Right? We will discuss the molarity, normality, and all the different type of like dilution, okay, or mixing of solutions tomorrow. Now, a small term I'm writing as time is less only, that is strength. Strength is not very common terms, right, in our books, so small only. Strength. The next term is strength. Right? So what is strength? You will see in solution, if by chance you see somewhere strength is written, what is strength? Strength is, carefully, it's weight of solute. Be careful, it is not mole of solute, it is weight of solute. Weight of a solute in grams, definitely, and here we are having volume of solution. Its volume of solution definitely in liters, and here it is weight of solute in grams. It's gram per liter. Strength, I'm saying once again, it is not a very common term. You will not see it many times. Very less in use, I can say, right? But the formula you should know about it. It's gram per liter, right? So very simple bit of question if I say. Here I'm saying we are having here, it is having 30 gram of urea in solution, 30 gram urea here, and here what I am saying, we are having 500 ml solution. We are having here, it's 500 ml solution. So please tell me the strength of solution. What are they asking here? Strength of solution. They are asking strength of solution. Yes, beta. Tell me the strength of solution. Fast. Simply weight of solute in grams divided by volume of solution in liters. If you have seen the term molarity, in molarity what we take? We take the moles of solute divided by volume of solution. So it is a little different from the molarity. I will discuss about the molarity in tomorrow class, right? So what is it? Strength we are discussing here. Weight of solute 30 gram and divided by volume of solution in liters. So I have to take what here? 0.06 or beta, I said 500 ml. Many of you making mistake. I said you have to take in liter. You have to take in liter, na? Volume of solution in liter. It's 500 ml, right? 30 is the mass of solute, okay? 500 ml. Make it liter. So what's coming from here? If you solve, what is coming? This 2 is coming. It's better. What is coming from here? 60. It is 60 gram per liter. In the most easy question, many of you did mistake. In liter, who will convert the given volume in liter beta? You will convert, na? 60 is coming, right? Fine. Again, I am asking simple question. Be careful this time. Here I am saying we are having, be careful. I am saying we are having 0.2 mole. Here I am saying we are having 0.2 mole of glucose. In solution we have 0.2 mole glucose, and here I am saying volume of solution is you can say 2 liter. Imagine 2 liter solution. It is 2 liter solution. So please tell me strength. carefully look at the solution. The molar mass of glucose is 180 gram per mole. The molar mass of glucose is 180 gram per mole, right? Here instead of mass they gave you what? Moles. But I need molar mass to convert moles into weight. Right, very good. What is it? 0.2 mole of glucose they are saying, but I have to find the weight beta. What is the weight? I will say 0.2 into 180. That means how much coming? 36 gram glucose. So 36 gram glucose is present in how much? 2 liter solution. This time volume is directly given, already given in liter. So no need to convert, right? Divide by 2. How much coming? 18 gram per liter. It's coming 18 gram per liter, right? Okay. Okay, bache. So this is your topic strength. Okay, small topic only. Will be less used in your questions. You will see it rarely, but still we have covered it. Okay. So tomorrow we will cover the molarity, normality, and remaining terms. Little bit about n factor also. Okay, bacha. I hope you enjoyed this session. So bye. See you tomorrow. Stay tuned. Okay, bache. Bye. Thank you very much.